Welcome to Chapter 5 of Node.js High Performance, Data and Cache. In this lesson, we're diving into one of the most fundamental aspects of any application: how you store and manage your data. Data is arguably your most important asset. You might run your application anywhere, but without your data, it is pointless. This includes all information your application manipulates, whether generated by your systems or created by your end users. If your application cannot work without a database, that database holds something irreplaceable. As your user base grows and your total dataset increases, planning how that data is stored and accessed becomes even more critical. And don't forget, you need a backup plan. Your users might accept losing 1 week of data, but they will never accept losing everything. Now, there are many ways to store data. The approach you choose depends entirely on what type of data you have and how large it can become. For simple key/value pairs, you might start with a flat file. An INI file or a JSON file works fine. But if that dataset grows to thousands or millions of records, a flat file becomes a liability. You need to think carefully and choose the best possible storage for your use case. Here is another practical tip: if you have multiple applications, it can actually be beneficial to converge on the same data storage solution for all or most of them. Choosing the second best tool and mastering it deeply is often better than using the perfect tool for every app and ending up with many tools you barely know. Deep familiarity with one storage system improves your operational confidence and reduces mistakes. The core storage categories to consider are: files on disk for simple or ephemeral data, relational databases like PostgreSQL or MySQL for structured data with relationships, NoSQL databases like MongoDB for flexible schema needs, and in-memory stores like Redis for high-speed, ephemeral data. Each has its trade-offs, and matching the right tool to the right problem is the first step toward high performance. Now let's talk about one of the most common performance killers in Node.js applications: excessive I/O. This is the problem of reading from or writing to disk or any I/O source far more often than necessary. When you build a custom data storage solution, you need to carefully plan when and how many times you read and write. Your host machine has a disk throughput limit, and hitting it is catastrophic. During local development, frequent disk reads may seem fine, but once you target thousands of concurrent users, you will start seeing a busy or mfile errors, and your application will fall apart. One common strategy to avoid excessive I/O is to read your data once at startup, hold it in memory, manipulate it there, and flush it back to disk only periodically. JSON is the most popular format for this kind of in-memory data store. However, this approach has a serious downside: your application must implement a single channel to read and write that file. If two processes write simultaneously without coordination, you will end up with corrupted data sooner or later. This is exactly why the book's recommendation is clear: instead of building custom data storage, use a dedicated database or data model server. Leave data storage to the professionals and focus on your application logic. The advantages are significant: you do not need to maintain the storage layer yourself, database servers are optimized for high-performance concurrent access, and they natively support multiple machines holding the same data so your application can scale horizontally. When choosing a database, focus on scalability and consistency first. Speed is harder to measure in isolation; it varies by application and use case. Pick a system you understand well, that you can replicate to a new host without panic, and that you can manage comfortably in production. That confidence is itself a performance advantage. A database you understand deeply will be tuned correctly; one you barely know will silently hurt you. Choosing a database management system, or DBMS, is one of the most consequential decisions in your application's lifecycle. The book is very direct: if you choose a DBMS, it is critical that you are comfortable with it. Do not put a server you are unfamiliar with into production; you will regret it. There are 4 key dimensions you must evaluate when selecting and operating a DBMS. The first is management. You need to be able to replicate your application scenario to a new host without too much effort. Look for systems that offer both desktop and web visual interfaces. Consoles are error-prone for complex operations, and visual tools give you automation and syntax validation. The second dimension is security. Default permissions are often dangerously permissive, especially on local host. Never leave default permissions in place on a production server. Audit who has access to your data and lock it down proactively. The third is backups. You must have a scheduled, automated backup plan, and, critically, you must have tested your rollbacks on a separate host. There is nothing worse than discovering your backups are corrupted during an actual outage. A cron job that exports data regularly and a documented restore procedure are non-negotiable. The author's advice: 1 or 2 backups that actually work are worth more than 10 that have never been tested. The fourth dimension is structure. Understanding how to organize and correlate your data for faster access is mandatory. Sketch your data entities and how they relate before you write a single query. Typically, in a growing application, one table will come to represent more than 90% of your database space, often a history or events table. You must identify that table early and optimize it aggressively. Consider whether you really need lifetime history in the database, or whether older data can be exported monthly to another format and removed. A database that can grow is good, but growth is not the same as performance.